Picture a massive spacecraft erupting into a fireball right outside your window. In theaters, you expect to feel the bass rattle your seat as a deafening boom fills the room. But out in the actual void, that exact same eruption happens without a single decibel of noise. Complete, eerie quiet. It feels entirely wrong. If a rupturing engine or a dying star is violently throwing off unimaginable amounts of energy, why can't we hear it? We naturally link high energy with loud noise because of how life works here on Earth, but that assumption exposes a blind spot in how we understand what sound actually is. To see where our intuition goes off track, we have to look at the thick blanket of air wrapped around our planet. Down here, sound starts as a physical vibration. When you speak, your vocal cords shake. That shaking pushes against the air molecules tightly packed around you. They bump into their neighbors, carrying kinetic energy forward, crashing into your eardrum and forcing it to vibrate. It is a mechanical relay race. Without a dense material, like air, water, or steel, to pass the baton, the wave stops instantly. And that is the problem with deep space. It is a near vacuum, stripped of the dense matter we swim through on Earth. There are stray dust particles floating out there, separated by kilometers of pure emptiness. When an engine fires, the initial shockwave pushes out, but there is nothing nearby for it to bump into. The energy simply dissipates into the void. There are a few localized bubbles where this rule breaks down. Take the International Space Station. Inside that hole, astronauts have imported a thick, pressurized atmosphere from Earth. The air molecules are packed tightly enough that alarms, fans, and human voices carry perfectly well. Even outside the station, if an astronaut placed their gloved hand directly against a firing thruster, the metal itself acts as a medium. They would feel the mechanical shaking ripple straight through the solid hull. But let go of the ship, and the connection is severed. The silence strictly dictates every empty gap between planets and stars. Looking at vintage NASA instrumentation like this, you might wonder about the sounds of space recordings the agency occasionally releases. Our dishes and instruments are constantly pulling in data from across the galaxy, but they are capturing electromagnetic radiation, things like radio emissions, plasma waves, and magnetic fluctuations. None of those are acoustic waves. Scientists map those invisible data points to audible frequencies, artificially translating the math into sound so they can listen for complex patterns. This data overlay image from the Martian surface hints at where we can actually find organic acoustics beyond our world. You have to land on a planet with a true atmosphere. Because the Martian air is extremely thin, about 1% the density of our own, the mechanical chain reaction struggles. Any noise you made there would sound incredibly quiet and muffled. What we experience as loud, clear audio is a geographic anomaly, entirely dependent on the heavy blanket of gas we happen to live inside. Without matter to push against, mechanical waves cannot travel. Filmmakers add roaring thrusters and booming lasers to space battles because humans are hardwired to associate high stakes with loud noises. A completely silent dogfight would feel weirdly detached to an audience. That absolute quiet serves as the clearest physical proof of the unimaginably vast distances separating absolutely everything in the cosmos. The physical rules out there don't cater to how our bodies evolved. To grasp the mechanics of the universe, we have to be willing to leave our senses behind.